20 in your packet. Okay, so we're going to go over some vocabulary. So the X-intercepts, also known as zeros, also known as solutions of a function, are the values for which f of x equals 0. Okay, the 0 of a function is the x-coordinate of the x-intercept of the graph. A function f of x is positive if the graph moves upward as you move left to right. A function f of x is negative if the graph moves downward as you move from left to right. For nonlinear functions, the average rate of change between 2 points is given by the slope that is this equation. Now, you have to have this equation memorized. This is not going to be given to you. This is your slope formula, and like at this point in your life, you should know this, okay? The 3 different key features that we're going to learn about are identifying the zeros, determining increasing and decreasing, and the average rate of change. So basically we're talking about the x-intercepts. We're talking about increasing and decreasing, which we'll go over in just a second. And basically average rate of change is just a fancy phrase for slope. The zeros of the following graphs of exponential or logs. So this unit is basically just graphing exponentials and logs. Okay? So an exponential function is something that has a base and we're raising it to an exponent. Okay? Exponent of x. So for instance, we're going to determine the zeros of this. That's talking about the x-intercepts, right? Okay? So where does it cross the x-axis? When I talk about the x-axis, I'm talking about this guy right here. Okay? So right here where it crosses the x-axis, which is at what number? 2. So we have an x-intercept at 2, 0. Okay? Another way we could have done this, let's say that they didn't give us the graph, they just gave us the equation. Okay? So that means that we can take this equation and set it equal to 0. Okay? So when we set it equal to 0, we can solve for x. So we're going to add 4 to both sides. And that's going to give me 2 to the x equals 4. Now, how we're going to solve this is we're going to put this into log form. So we're going to start at our base, go to the outside, go to the exponent. So this is going to be log of base 2 of 4 equals x. If we plug this into our calculator, we're going to get x equals 2, which is exactly what we see on the graph. We know that it crosses at -4. So you're going to have an x-intercept at -4, 0, right? Now, if we set this equal to 0 and we solve, we're going to put this into exponential form, right? So we're going to start at our base, which is 10, go to the outside, and then finish at this number over here. So this is going to be 10 to the 0 power equals x plus 5. And we know that 10 to the 0 power gives us 1. And if we solve for x, we're going to subtract 5 from both sides. And that's going to give us x equals -4. Again, if they give you the graph, then just look at the graph and be like, hey, this is it. If they give you the equation, this is how you solve it. Okay? You need to know how to do it both ways. Because remember, your interim might ask you just the algebraic way or might ask you the graphic way. So now we're going to actually talk about domain and range. Domain and range. I love you guys, but like we still suck at it. Okay, so domain is talking about your x's. So if I were to look from the left to the right, domain is your left to your right. So if I'm scanning from left to right, where does my first x kind of start? Where does that blue line start? At x equals 0, right? Yep, this x-axis or this y-axis is 0, right? Yes? Okay.
Right here. This one, right?
Yeah. You see this blue line right here?
Yeah.
Where does it touch? At x equals 0.
I don't know if it goes left or right.
So
because
you
it's
always
curving
read
over?
left to right, so you start from left to right. What?
Is it because it's curving over?
Yep. Okay. So we're going to start at 0, and we're going to go, how far over does it go?
To infinity.
To infinity. Okay. So your domain is from 0 to infinity. Now, I put a parentheses here because if we type this into our calculator, if we type this equation into our calculator, we're going to hit that y equals, we're going to hit negative log of x, and we go to second graph, we see at x equals 0, what is the y?
Error.
Error. So, with that being said, we're not going to include 0. Okay? Okay? So, for our range, we're going to look at our highest y value to our lowest y value. Okay? So the reason why I wrote it like this is because you want your bottommost number to be on the left-hand side and then your topmost number to be on the right-hand side. So just like what happened up here at the top, we went from 0 to positive infinity. Here we're going from negative infinity to 1.5. Questions?
So your lowest number goes first to the highest.
Yes. Can you try number 2? Okay, tell me the domain and range for right now. Okay, so for on this one, our domain is going to be from what? What's the leftmost x value? Negative infinity, right?
What would have been 2?
Hmm?
What would I put 2?
So we're talking about our left to our right. So what's going to happen is we're going from left. Well, what's our farthest left x value? Okay, so when you're looking at your domain, you're looking at this line right here. What's your farthest left x value? Negative infinity, because it goes off the page, right? Okay, so we're going to say from negative infinity to what's our farthest right x value?
I put 2.
Well, it keeps going, right? Like it's going to go off that page, right? So we're going to say positive infinity because we can plug in any x value. If you don't believe me, we can come into our table or we can come into our calculator and we can do 4 raised to the x value, in parentheses, minus 1. Let me change my table set really quick. So if I go into my table, I can increase my x values forever and always, right? Okay. All right. For range, okay, for my range, we're going to look at our farthest down y value. What's our farthest down y value?
0.
Negative 1, right? Okay. And the reason why it's going to be negative 1 is, fun fact, right here, this little negative 1 out here is actually going to be something called your asymptote. We're going to talk a little bit more about that later. But, so for your range, you're going to have negative 1 to what's your highest y value? Positive infinity. Okay? Good so far. So we're going to start talking about increasing and decreasing intervals. On this first graph right here, going back to this first graph, is that decreasing or increasing? Decreasing. Okay? Where is it decreasing from? What's our farthest left x value? 0. What's our farthest right x value? Okay? So for our intervals of decreasing, we're going to put essentially our domain. Okay? Over here on number 2, is it increasing or decreasing? Are we going up the roller coaster or down the roller coaster? Up. So we're increasing, right? What's our farthest left x value? Negative infinity. What's our farthest right x value? Positive infinity. That is how you do increasing and decreasing. Okay, for logs, it's a little easier just because they don't really change direction much. Okay, fun. All right, so average rate of change. Y'all know what average rate of change is. You've been taught it multiple times. So it says compute the average rate of change between the points 1, 0, which is going to be our x1, and 2, blank for each graph below. All right, so here's the deal. We know that we have to use the formula y2 minus y1 over x2 minus x1. Okay? But we need to figure out what y1 and y2 are. So in order to figure out what y2 and y1 are, I'm going to plug in this x1 and x2. So if I plug 1 into this equation, I'm going to get 2 to the 2 times 1 power minus 10. Well, 2 to the second power is 4. 4 minus 10 is going to give me negative 6. So negative 6 is going to be my y1. So negative 6 is going to be my y1. I'm going to take 2 and I'm going to plug it into this equation. So 2 to the second times 2 minus 10. Well, 2 to the fourth power is going to give me 16. 16 minus 10 is going to give me positive 6. So that's going to be my y2. Okay? Another way you could have done that without having to plug in is you could look at when x is 1, your y value is negative 6. And when x is 2, your y value is positive 6. So we're going to take both of these points and we're going to plug them into this equation. So we're going to say 6 minus negative 6 divided by 2 minus 1. So 6 minus negative 6 is going to give us 12. 2 minus 1 is going to give us 1. So my average rate of change is going to be 1. So if you either plugged into your equation, you should have gotten 1, 3 or 2, negative 9. You can also just look at the graph. And that's going to give me 1, 3 here and 2, negative 9 here. Okay, it's a lot more challenging to look at the graph, so that's why we have the equation there. But now we're going to plug into our slope formula. So we're going to get negative 9 minus 3 over 2 minus 1. Well, negative 9 minus 3 is negative 12. 2 minus 1 is 1. So our average rate of change is negative 12. Now, here's the deal. Average rate of change is supposed to be positive. It's supposed to be positive. This negative is telling me that my graph is going down. Okay? We're going to talk a little bit more about that, but for right now, we're just going to keep this negative 12. Okay, so we're looking for the x-intercept on this one. So it crosses at negative 1. So we're going to have an x-intercept at negative 1, 0. For intervals of increasing or decreasing, well, it's increasing, right? So it's increasing. Okay? And it's increasing over the interval, this point right here, all the way to this point. Well, this is roughly about negative 1.5. Negative 1.5. And then it increases all the way to positive infinity. Average rate of change, it's going to kind of fluctuate between what 2 points you chose. So, like, for instance, I would use the points probably 4, 1. Or I could come into my graphing calculator and actually find exact points. So, if I plug in this formula, or this equation, I'm going to look at the table, and that's going to pull up points that I can actually use. Don't use decimal points if you can avoid it, solely for the fact that otherwise it's going to be rounded, right? So, for instance, I'm going to use 2, 0. That's not right. I don't think this graph actually looks right. Yeah, this graph's not right. Look at it. It's not right. Okay? So that's why you always want to make sure that you plug it in or you ask which one they're talking about.